Hi everybody, this is Dr. A, and in this video we are going to be exploring an example of identifying linear equations. So we're going to have a few different equations here where we're going to be asked to determine if they are linear or not, and then state why they are linear or why they are not linear. So just like always, whenever you're doing anything involving mathematics, it's best to write everything down. Write everything down on your own paper in your own notebooks because that's the best way to learn it. Learn by doing it. Don't just watch this video and just think you can watch or listen and know how to do it. You got to write it down. So let's go ahead and get started. We're going to start by writing given. And here's our given information. We're going to say let x and y be the independent and dependent variables, respectively. Okay. And so again, we're going to be asked for each of these equations I'm about to list, which equations are linear and why. All right, so let's write our first equation, part A. We're given the equation 3x plus 2y equals 7. And then equation B, we're going to be given sine of pi over 2 times x minus 4y equals e squared. And then equation C is going to be x times y squared equals 3. Equation D is sine of x plus y equals 0. And then equation E is e to the x minus 2y equals 4. Okay, so here are our 5 equations. We need to go through each one of these and determine which ones are linear, and then why is an equation linear or non-linear. Okay, so we've written the given information. Let's write solution now. So let's go through each one. Let's look at part A, or equation A. Equation A states 3x plus 2y equals 7. Well, this equation is linear, okay? So we're going to write this is linear, all right? Why is it linear? Well, if you look at it, remember, what is the definition of a linear equation? Well, a linear equation relates these two variables, x and y, your independent and dependent variables, by a constant value, which we typically call that the slope, okay? And so we can rearrange this and put this in slope-intercept form if you want, or you could just go ahead and look at it immediately and say it's already in standard form, right? So this equation is already in standard form for a linear equation. Remember, what is standard form of a linear equation? A linear equation has a standard form of ax plus by equals c, where x is the independent variable, y is the dependent variable, a, b, and c are constants. And so we already have it in that form. Capital A, the constant a would be 3, the constant b would be 2, and the constant c would be 7. So you can look at it and say, well, it's already in standard form for a linear equation, thus it's linear. Or again, you could rearrange this equation and solve for y, and you would rearrange it to get it in slope-intercept form, which has the form y equals mx plus b, and you will see that that slope m would be relating your independent and dependent variables together by a constant, the constant being the slope, okay? So, so again, equation A is linear, all right? Let's look at equation B now. Equation B is sine of pi over 2 times x minus 4y equals e squared. Let's make sure I wrote that right. Yep. So is this linear or is it non-linear? Well, when you look at this, you may first think, well, it's non-linear because there's a sine operator here. But this equation, in fact, is linear. It is, in fact, linear. How do we know that? Well, even though we have a sine operator here, the sine is operating on a constant. Pi is just a constant. Pi is a number, right? 3.14, so on and so forth. So when you take the sine of pi over 2, you are getting just a constant number. The sine of pi over 2 is just a number. Now, sine of pi over 2 happens to be the number 1, but it's still just a number, okay? We also have negative 4 here is just a constant. That's the constant in standard form that we call capital B. And then E is what we typically call Euler's number. So the number E, named after a mathematician, last name Euler, is equal to 2.718, so on and so forth. So this equation is, I'm going to write basically the same thing as part A, is in standard form for a linear equation. Okay, so that's linear. What about equation C? Equation C is x times y squared equals the number 3. So is this linear or non-linear? Well, it turns out this equation is non-linear. And we can think of it as non-linear for a couple of reasons. The one reason is that x and y specifically are not related by a constant of proportionality. Because you have a y squared here, okay? So you have x times y squared. So you don't have just the independent variable x and the dependent variable y only related to one another by constants. You have a power happening here. So that brings me to my next observation. The y is squared, which means that no matter how you would try to manipulate this equation, your one variable will always be squared, no matter, if I divide by x on both sides. If I take a square root, there will always be a squared somewhere. One variable will always be squared, and the other variable would always have a square root, no matter how I try to rearrange this. So like if you tried to solve for x, if I just tried, let's just try it out, right? If you try to solve for x, you would get x equals 3 over y squared. Again, x and y are not related by a constant. 3 is not relating x and y together. 3 is somehow relating x and y squared together, okay? What if you tried to solve for y? Well, if you tried to solve for y, what would you get? You'd get, plus and minus the square root of 3 over x, and that's a root equation. That's a radical equation, not a linear equation, okay? So you can think of this as the variables are not related by a constant. And you could also think of it as, we could say also one variable will always either be squared or in a square root. Okay, so that's equation C. What about equation D? What was equation D from our given statement? Sine of x plus y equals 0. sine of x plus y equals 0. This equation is nonlinear, okay? Why is this equation nonlinear? Well, you have a sine operator, but unlike our equation in part B, this sine operator is operating on a variable, okay? So we have the sine of x. We have the sine of that independent variable x. So no matter how you look at this, either x will be trapped inside of this sine operation, or if you tried to solve for x, you would end up with an arc sine. You would have, an arc sine operating on the y variable. So because we cannot, so similar reason as part C, we cannot isolate either variable outside, let me rephrase that. We cannot isolate both variables outside a trigonometric operation, and thus cannot establish a proportional relation between x and y. Other ways you can think of this, you can also think of it as you can never get this equation in standard form for a linear equation. You can never get it in the form of a constant times one variable plus another constant times the second variable equals a third constant, and the same is true for equation C. You can never get it in standard form. So there's a few different ways you can kind of think about why these are non-linear, okay? And then let's look at equation E now. Equation E is e to the x minus 2y equals 4. Let me just scroll back up and double check that. Yep, minus 2y equals 4. So is this linear or non-linear? Well, this one is also non-linear. And again, similar way of thinking as equation D. If you look at this, our independent variable x is trapped in the exponent here, okay? So similar to equation D, we cannot isolate both variables outside an exponential or log function, and thus cannot establish a proportional relation between these two variables. And similar to equation D, we could also comment on how, because we cannot pull both of these variables outside an exponential or log function or log operator, we can never get this equation in the standard form of a linear equation, which has the form ax plus by equals c, okay? And again, you can try all you want. You can rearrange this, and you could try to solve for x, and you'll see a natural logarithm, an ln will pop out somehow, or and the y would be trapped inside of that, or x will just remain trapped in the exponent of Euler's number e. So a few different ways, good ways to kind of think about that. So that concludes this video on identifying linear equations. If you liked it, you can hit like and subscribe on the video below.